Hello, and welcome to my show, Differentiating with Bob. Today, we will be talking about, you guessed it, differentiating logs and exponents. Woo! My name is Bob, by the way. Did I mention that? Well, my name is Bob. Now, what is a derivative? You might be asking yourself this question since, of course, I brought this topic up. Well, let me tell you. It's quite simple. A derivative is finding a rule for the rate of change. It's simply the derivative of y in terms of x. This is my lovely wife, Suzanne. Suzanne's British. Suzanne, say hi.
Hello, Bob. See, I've got a little bit of an inquiry here. But Bob, how does that work? I don't understand what the concept doesn't make sense.
Oh, Suzanne, that is a great question. Let me address that question, Suzanne. Well, it's not exactly like the derivative per se. There's a bit more to it. Just a little bit, okay? So bear with me. Take the concept of derivatives, okay? But we're going to be doing what we call the chain rule, okay? You see, here you can see that one thing that's different is that you bring whatever the derivative of inside the parentheses comes out and is multiplied by the coefficient. Okay? That's a major difference right there, Suzanne. And then that is multiplied by the exponent minus 1. So really, there's two simple steps. It's really that simple, okay? You follow me, Suzanne? You get me? You usually get me. Do you get me today? You get me, right? You get me?
Well, Bob, I see, I get it, but, like, what does that have to do with logs and exponents? Like, it's not clicking for me right now. Can you explain that for me, please?
Yes, Suzanne, I'm sorry. I probably haven't made myself clear. I only described derivatives, the chain rule derivatives. Well, let's put it this way. This concept remains the same for logarithms and exponentials, okay? The concept of multiplying the outside coefficient by the derivative of the parentheses and multiplying the outside coefficient by the exponent of the parentheses minus 1, okay? That stays the same for both.
Oh, okay, this is making sense. So then, does this mean... Let me show you. I can't explain math. You know me, English major. I can't put numbers to words. So let me just go and board here and explain. Like, write this down, see if you get me. So here I go and I brought the derivative down, right? The 3x, and then multiplied 3 by the exponent 2 to get the 6x, and put it in front of the e. I don't change what's on top. The exponent, right?
Oh, Suzanne, that is exactly right. Don't you dare touch that exponent. You don't change what's on top of e. That is genius. You are genius. I love you. Exactly. Because, remember, the exponent never changes. Good job, Susie. Little genius, you.
Oh, yay! Thanks, Bobby! But one last question, though. Just my last question. I promise I won't ask any more. I'm getting this. It makes sense. I get it, okay? And you know how I am about getting math. So, what about ln, you know? Because that's a little trip me up.
Oh, Susie, there you go with your genius questions. Well, let me address that for you right quick. It's quite simple. There's not much difference. Good question, Susie. It turns into a fraction. Okay, that's the only difference. Now, let me go back to my board to give you an example. The concept, okay? The concept remains. You find the derivative of inside the parentheses, okay? But right here, you multiply it by the coefficient, and you put what's in the parentheses on the bottom of the fraction. You get me?
So, let's recap real quick so I can make sure that I'm digesting this. So, what we do here is, step 1, okay, you find the derivative of the exponent, which in this case would be 2x to the 4th minus 6, it would be 8x cubed, and then you bring that in front of your e. You know, because essentially there's a 1 in front of the e, so you multiply the 8 by the 1, you get 8x cubed, and you leave the e the same, and that's it, right? That simple? Right? I mean, this looks like it makes sense, I think. Right?
That's right, Suzanne. Now, don't forget, for ln, it should be a fraction. Don't ever forget. What's in the parentheses goes in the bottom of the fraction. Just remember that, and you should be straight.
Oh, thanks, Bobby. This is so exciting, all this math. It's just great, isn't it? I prefer English, but you know the math is great.
Oh, I'm gonna act like you didn't say that. No problem, Suzanne. No problem, Susie. Mother's life, though. But you know, no problem.
Before we go, we have an important question to ask you. What do organic mathematicians throw into their fireplaces? I'll give you a little bit of time. Think about it. Ready? Natural logs! Oh, that was funny. The mad jokes. Ooh, not even Bob would be proud of that, to be honest. Thanks for watching. That's all, folks. This project and production has been a Meli Ace.